Hello, so let us look at some problem set questions from trigonometry. Here comes the first one. Find the amplitude, frequency, and horizontal shift. In this case from a parent function, and we have to state what the parent function was. Alright, so here we have y equals 3 cosine x minus 5 sine of x. Okay, so we have sine and cosine have the same angle, x and x. And they're connected by, subtraction sign. So in fact, one thing that which you can think about would have been something like this. You see there are more than one answer, but one thing that which you could have done is, what if you to compare this one to sine of A cosine of B minus cosine of A sine of B. In other words, this actually comes from sine of A minus B, the difference of the angle for sine function. Now, then you will see that sine of A corresponds to 3. I understand the sine of A, value of the sine of A cannot be equal to 3, but it corresponds to 3, while cosine of A corresponds to 5. If you're tossing the sine of B corresponds to x, then that's what we could have happened. Now, then knowing that, what if I were to give you a triangle? Now, not any triangle, but sine, meaning given that this is a right angle, this is a angle that which we are looking at, let's call that angle A. Sine corresponds to the opposite side, so what if I call this one as 3, and cosine corresponds to 5, so this one, adjacent side, will be 5. Then using the Pythagorean theorem, we should be able to figure out the hypotenuse. So there will be square root of 34. Alright, knowing that, then wait a minute. If I have square root of 34 dividing both numbers, then I can actually convert this one into sine of A from this triangle, and this one to cosine of A. So what I'm going to do is this, y will be equal to, I'm going to rewrite this one as they are. Now, what if I decide to divide by radical 34? But I simply cannot divide. If I were to divide by something, then as long as I multiply by the same thing, then I didn't change the expression. So that's basically what happened. Then here, if I have to rewrite this one, square root of 34, then this becomes, in fact, difference of the angles for sine function. So sine of, now what's the angle A? Let's try to use the calculator to just calculate that for now. Of course, I could actually write it as a arc sine of 3 over 4, square root of 34, or actually, there will be the exact value, but I can just use the degree measure or radian measure, it doesn't really matter. Let me just use the degree measure. How about that? Second sine in this case would have been 3 divided by radical 34. Then here we get 30.9 degrees. So that's basically what we end up getting. So here 31 degrees. How about that? 31 degrees minus x. Now, if I have to rewrite this one, I can write it as negative because sine function negative. Since sine is an odd function, we can bring the negative inside or outside. It doesn't really matter. And then sine of x minus 31 degrees. So in fact, in this case, amplitude would have been equal to radical 34. Frequency will be equal to 1 because coefficient of x, and horizontal shift would have been equal to 31 degrees to the right, positive 31 degrees. And given that our mother function is, or parent function is, y equals sine of x. Alright, let's move on to the next question. Number 87. Let y be the vertical distance away from the lowest. So from here, in this case, y value will be equal to 0, and in this case, y value would have been difference between where the tip of the hour hand is to the bottom of the clock, and so forth and so on. And we're going to assume that the 12 o'clock we are right up here, and 3 o'clock we are about here, and then 6 o'clock will be equal to 0. So in other words, if I were to use the chart, simple chart here, let's say this is x being the time and then y being the height, 12 o'clock or 0 o'clock, let me just call it as a 0 hour, we get 6 because it's the highest position. 3, we know that it's a 3 because it comes to the middle. When it's 6 o'clock, it's go all the way down to 0. And then when it's 9 o'clock, we are going back up to 3. And 12 o'clock, we're going back up to 6. So in fact, you will realize that the period is equal to 12 hours. That means because it makes up one circle every 12 hours, then what is the frequency which will be needed to make the equation? It will be simply 2 pi over 12, which is equal to pi over 6. How about the amplitude? The amplitude is, since my value goes as high as 6 and as low as 0, then our amplitude will be half of that, which will be 3. Now, that means our vertical shift can easily be detected as 3 also. If you had to sketch this one, it would have been something like this. Here we start from the top. Okay, the last portion is a little bit off. But so given that this is like a 12 o'clock, this is 6 o'clock, this is equal to 0. Type is 6. Now, if I want to find out the equation of this one, you can imagine, if you imagine the midline would be around here, then you can, I'm hoping that you can easily see that this point where the sine curve starts, because that's what I asked you to do using a sine function. So where the sine curve starts is right over here. It must correspond to 3 because midway between 6 and 0, or 12 and 0, 12 and 6. Now, then we have y equals, amplitude doesn't change, so we have 3, but since we're going down first, we're going to have -3. And then sine, so you see between sine function versus cosine function, the frequency doesn't change, so I'm just going to write down pi over 6. And x, because we have a horizontal shift over by 3 units, so x minus 3. Of course, you could have gone horizontal shift 3 units to the left, that would have been perfectly fine too. And then we have a vertical shift of 3, so that becomes our final answer. Alright, let's move on to the next question, number 88. Find the value of x where this one is true. Okay, so if I were to rewrite this one, this is in fact equal to sine of x, which is greater than square root of cosine square x. Because that's what, using the Pythagorean identity, we can see that 1 minus sine square must be cosine square. Now here we get sine x has to be greater than absolute value of cosine of x. That's what square root of perfect square is. Then we have to realize that sine is always greater than 0 or equal to 0. On which quadrant do you see that? That's right. This implies that x has to be 0 through, not 360, 0 through 180, because to be in the first and second quadrants. So this one, domain has been restricted a little bit. Now, then knowing that within that domain, when do you realize sine of x is in fact equal to cosine of x with the absolute value? This tells us that that is true if x is equal to, let's try to use the degrees because that's what we have. X is equal to 45 degrees or 135 degrees, because in that case cosine would have been negative, but due to absolute value it becomes positive. Then here we have 0, 180, 45, 135. So we have 3 intervals that will be nice for us to think about. Then here, between 0 and 45 degrees, what if you have to use a 30-degree angle? If you have to use 30-degree angle, sine of 30 is 1/2, while cosine of 30 is radical 3 over 2. Sine cannot be greater, so this section is out. Here, maybe you can use 90, maybe. I could use 30 degrees, and then I checked it doesn't work. How about 90 degrees? Sine is equal to 1, cosine is equal to 0. So it works. How about here? Maybe 150? Then once again, sine is only what? 1/2. Absolute value of cosine of 150 would have been radical 3 over 2. It became positive because of the absolute value. Now, then this one is out, so therefore our answer becomes right over here. But since it cannot be underlined, so we'll end up having open circles. Alright, let's look at number 89. Okay, we have a right triangle. Now, you know what? Since it didn't say anything, one of them has to be a right triangle. So then let me just try to draw a picture for you and then see what we end up getting. So assume that, this is the right angle. Let us assume that C is the right angle. And this is A and this is B. Notice the sine of C here is equal to 1. We know that because it's a 90-degree angle. But did you realize that angle A and angle B are complementary? In other words, sine of A is equal to cosine of B. When the angles are complementary, then cofunctions are equal to each other. That's what cofunctions are. So then, by applying that, we get to realize that this one can be rewritten as cosine squared B, because sine of A is equal to cosine of B, as we can see, plus sine square of B plus 1 square. Then what is these two equal to each other? Sine squared plus cosine squared. By Pythagorean identity, this is equal to 1. And 1 squared becomes 1. Therefore, our total answer becomes 2. Alright, let us look at number 90. Now, x squared cosine of... It's very hard to put them together. Now, in fact, there is a way for you to do this one. Assume that if you're to get into BC calculus class and then under the topic of sequence and series, then you will be able to realize how you can expand cosine as a series of polynomials. Then in that case you can get the answer in another way. But for now, why don't we try to just simply sketch it and see what we end up getting? Because after all, sketching is not a bad way to solve a question. So here, wait a minute. If I were to add cosine, then we can say that. Whoops. X squared plus 1 must be equal to cosine of x. So what if I were to sketch x squared plus 1? That's rather simple. But how about cosine of x? Starts from 1 and it comes down, goes back up, or it comes down this way too. Wait a minute. Where do you see a point intersecting between these two functions when x equals 0? And you can see that right away here. Number 91. Sine of x is equal to 2 cosine of x. Then what is cosine square of x? There are many different ways of approaching this one, but notice the sine x and cosine x is also the same. So if I were to divide both sides by cosine of x, then we get tangent of x. Oops. Tangent of x is equal to 2. Now that means in a triangle, tangent, which means opposite over, if this is angle x, opposite over adjacent will be 2 over 1. It doesn't look like it here, but let us assume that it is. Then we get to realize that the hypotenuse is square root of 5. Here then we get to realize that cosine of x must be equal to 1 over square root of 5. Now then what is cosine square of x? Cosine square of x is equal to squaring that, which becomes 1 over 5. So hence becomes 1 over 5 becomes our answer. Number 92. Here we have cosine of x and cosecant of x. Okay, we know that the cosine of x is equal to negative 1 over 4 sine of x, because cosecant is 1 over sine. So if I were to put it correctly, then it would have been something like this. Now we have sine and we have cosine and sine here. So what if I multiply by 2 sine of x? In fact, some of you guys might be thinking, How do you think of that? You see, if you memorized all the trick ratios and chart and identities and all those things, it will be easier for you to recognize that. Without memorization, oh, it's going to be very tough. So here we get sine cancels out. 2 cancels out with 4 becomes 2. Here, in fact, this is double angle formula for sine, so we have sine of 2x is equal to negative 1/2. Alright, how can you see negative 1/2? In fact, sine is negative on the third and fourth quadrant. So let's look at it. There, and then the reference angle is equal to 30 degrees. So 2x can be equal to 210. That's possible. That tells us that x must be equal to 105. Alright. But sine is also negative on the fourth quadrant. So therefore, if you have to follow that one, then 2x, the angle must be equal to 330. So that implies that we have 105, half of that, because if 2x is equal to 210, then x will be equal to 105. Here, x will be equal to, that's right, 165. Alright, now, then let us move on a bit further. Oh yeah, that's right, some of you guys might be thinking, isn't the angle of 260? You see, x is equal to 360, but not necessarily 2x. You see, then, what we can realize is that 210 can imply another angle. In other words, 2x can be equal to 210 plus 360, which is, it can come back to where 210 was after circling it around one time already. So this becomes then 570. 210 plus 360. Now then that, if you have to divide this one by 2, then what we end up getting is 285. Alright, that's right, we're not done yet. Yes, we have one more. What if 330 is not just 3, but after circling it around one time already, so therefore adding 360, that means we get 690. So when you add 690, then half of 690 becomes 345 degrees. And that becomes our answer. Alright, so let us move on to the next question. Number 93. So we have cosine of 20, cosine of 40, cosine of 80. We have to calculate what those things are. So first thing that you may come to your mind would have been cosine, a double angle formula for cosine. Even though that's nice, but it can be somewhat messy. You see, then there's another double angle formula, not for cosine, but for sine. So cosine of 20, cosine of 40, and cosine of 80. What if I multiply by, as I mentioned, 2 sine of 20? Then denominator will be still 2 sine of 20. But numerator, the first portion becomes 2. First portion becomes sine of 40. And I'm going to copy the rest of them with the red color. Then we had a cosine of 40. And then cosine of 80. But here, what do I realize? I can multiply top and bottom by 2. Then the first 3 factors becomes cosine of 80. So here we get cosine of 80 times, sine of 80, my bad, degrees, and cosine of 80 degrees all over 4 sine of 20. Now once again here, this calls for the previous cases. So what I can do now is if I want to multiply top and bottom by 2, then the numerator becomes sine of 160, while the denominator becomes 8 times sine of 20. But you can see that sine of 160 and sine of 20 must be equal to each other, because in case of sine, when the angles are supplementary, as long as their reference angles are the same, then they'll be same value. So our final answer becomes 1/8. But what they want us to do is adding the numerator and denominator, so our answer becomes 9. That becomes our final answer. Alright, let's look at number 94. Sine of 2x is equal to a radical 2 over 3. Now, then, wait a minute, then what is this? This is in fact 2 sine of x cosine of x is equal to radical 2 over 3. How about on the other side? So the fact that we have something raised to the 4th power, in fact, that's equal to sine of x minus cosine of x, raise this one by 2 power, and then raise the resultant by 2 power. That's also another way for us to do it. And in this case, the inner portion becomes sine square x minus 2 sine x cosine of x. You can do this one by FOILing if you want to, of course, but you can memorize this one since it's perfect square. We have cosine square x, and whole thing divided by 2, raised by 2nd power. But interestingly, what we end up getting is this. You see, this one, these two combined together becomes 1, and 2 sine x cosine of x is a radical 2 over 3, so we can simply put a negative radical 2 over 3. And we want to raise this one by 2nd power. That's basically what we're trying to do. Now, then our value is simply, all we have to do is, square this one, and then when you simplify, then it becomes our answer. If you had to do that, then this would have been, here we have 3 minus radical 2 over 3 squared. Then obviously the denominator becomes 9. Here we get 9 minus 6 radical 2, and then plus 2, which ends up being 11 minus 6 radical 2 over 9, and that becomes our final answer. Alright, that's it. We'll stop here, and I'll see you later. Bye-bye.